Now, as soon as we moved to SwiftUI from UIKit, which is something I forgot to mention, we started to migrate our constraint base to the SwiftUI new framework. The migration was really smooth. It's a really good experience. But the problem we have now is that we had through this year is that the navigation of our application wasn't reliable enough for us. The navigation is the subtle art of changing the current location without screwing everything up, meaning that you need to go from one place to another and focus on the way you are transitioning between screens, because it's easy to define the starting point, it's easy to define the destination, but what happens in between, it's the thing that we are trying to focus on for today. Hi again. Today we are here to talk about navigation, and this is because mostly last year's Swift Heroes, I've been asking speakers, mostly every one of them, how do you do navigation in SwiftUI? And the questions were kind of mixed up. So first of all, let me introduce ourselves. We are Stefano and Andrea. We work for Synesthesia, you already know that from the opening, and we are working on iOS on various levels. And yeah, today I'm here before we start to give you a little bit of context about what we are doing in Synesthesia and why we are here talking about navigation. So basically our work is crafting new apps for various kinds of customers, from sports, sometimes finance, you name it, we probably did it, from small projects to medium, large ones. We are given constraints to produce our applications on the App Store or business distribution, and these constraints may change according to our customers, but usually they want us to support as many old devices as possible. Maybe at some point in the future, they will want to integrate something new, something strange, something we didn't think about at day zero. Or maybe they will want to drastically change something, remove it from the code base because they don't need it anymore. Usually the thing is we want to, we want you guys to be fast and flexible. You need to be able to respond to our changes and to, all our change of minds. Let's put it in this way. And of course, nobody likes bugs and regressions, so we also have to take care of that. Now, I already briefly talked about this last year, but our solution to the problem, since we are kickstarting multiple projects, is to create a skeleton. So our skeleton, like probably you have yours in your projects, it's a basic empty app with some kind of, extensions, utilities, you name it, you have it, that basically gives your team a starting point for new projects. The current status of our applications, of our skeleton application, which is evolving throughout the years, is a modular application based on Twist. We had a workshop yesterday morning about this. We can create white labels. We can have modules and separated features that we may plug in. In the same project, we may have multiple apps. Some of those apps are taking from some of the features and mix things up. This year, we conquered iOS 15 as minimum requirements to support older devices, because until last year, I think we were stuck on 13 or something like that. So we migrated away from RX Swift, which, as you probably know, I used to love a lot. So yeah. And we call this fast development, skeleton-based development, actually. Now, as soon as we moved to SwiftUI from UIKit, which is something I forgot to mention, we started to migrate our constraint-based, in some cases also XIBs-based. Luckily, we don't have storyboards in our projects. to the SwiftUI new framework. The migration was really smooth. It's a really good experience. Actually, we were able to achieve something that wasn't possible, or at least we weren't capable to do in UIKit. But the problem we have now is that we had through this year is that the navigation of our application wasn't reliable enough for us. Now, the navigation, as someone said once upon a time, is the subtle art of changing the current location without screwing everything up. Meaning that you need to go from one place to another and focus on the way you are transitioning between screens, because it's easy to define the starting point, it's easy to define the destination, but what happens in between, it's the thing that we are trying to focus on for today. So we did try to split our mental map, mind map of navigation into three main core concepts. The first one is that usually to trigger a navigation, you receive some fancy input from your users, right? A button or maybe something automated like a push notification or, I don't know, whatever event may occur on your application. At that point, usually it's on the view side. So the view, it's something that you usually don't test because it's hard to do that. You want to test the business logic of your application. So usually you take the input, you take it in the most simpler way possible, and you pass it to some business logic component. For us is a view model, and we will talk about view models, but it's not something that the navigation system is not working only with MVVM, but also is applicable to other concepts. So again, your business logic will calculate your destination. If this, then navigate there, otherwise do nothing, something like that. And finally, you will have a way to navigate to your destination, again, without, hopefully, problems. Just a random image over there. The pattern, as I explained, you get the view, you receive the input action from models or by clicking elements in the list, you pass that to the view model, you calculate the parameters of your navigation, like if you are selecting a product from a product list, you will likely want to have the selected product as the parameter for your navigation. And then we want to define some kind of external actor that will take the lead on the navigation itself, okay? Now, how does this work in SwiftUI, and why didn't this thing work for us? Now, the official SwiftUI way is to have a navigation view. You can have multiple components in there. Then you get a custom object called the navigation link. You need to embed in there the destination view. You may have some text and other components defining your single items. But you might probably notice that I'm outdated here. So at some point, after releasing iOS and the others 16.0, this became deprecated, only to be able to move to a different type of navigation by using NavigationStack and other components in SwiftUI. This is more or less the same, but the problem is that it's only iOS 16 plus compatible, which is not meeting our requirement starting from iOS 15. Let's try to analyze that. So the pros of this approach is that anybody can look at that and kind of understand what's going on. You get a stack, you get some items, you get the destination, everything is in there. You can also, I didn't experience that much, honestly, but you can also tie the navigation stack to some state variables so that you can drive the state variable to kind of move across your navigation. And it's also cross-platform and universal, meaning that NavigationStack will adapt automatically on all the contexts that you might need in your application. macOS, iOS, visionOS, etc. just for a reference, how many of you are dealing with multi-platform architectures and applications by raising hands? Okay, so a few of you. This also means that it's not quite a common scenario to deal with multi-platform architecture. It's something that we want to do, but it's not so common. The cons, the downsides of these things, as I said, it needs iOS 16, so not suitable for us unless creating a new component around it with some if-elses inside. It's complex to scale because if you are dealing with a multi-feature application and you are handling a big list, a menu list of places where you can go in your app, you need to place them all in the same place in the view. It might not be the best use case and easy to do. It's not easily unit testable because views are really hard to unit test. You can UI test them, but it's out of scope for us at the moment. Still, it's unclear to me how you deal with async logic, because yes, you can drive this a state variable tied to the navigation, but it's still in the view. It's not immediate to understand what's going on. Async logic, I mean, I tap a button, I wait a couple of seconds for a network call, and then I navigate to my destination. So not compatible with our beloved approach, and also presenting not SwiftUI screens requires wrappers with, I don't know, UI view controller, representable, stuff like that. Now, one thing that really triggered me when I discovered this is how you can present Safari controller, which is a standard component to present web views, actually web-based contents, not web views, in your application. There's this great tutorial about that, and it's a list of hacks that you might need to do in order to be able to achieve this very simple task, because it's quite common to click a button and move to some kind of external website without designing all the controls in a web view. So Safari controller is there for this. So yeah, for us, SwiftUI navigation is definitely not enough. And this is basically how we did solve our thing. So we moved back to UIKit in a way that we try to embed in a SwiftUI screen. So basically what we tried to do was to focus on SwiftUI for the single screen, the main unit of your app, and then use UIKit to navigate. But how to do that? Now, as you probably know, UIKit or SwiftUI, one of the two frameworks, is exposing this UI hosting controller, and also there's a counterpart for macOS, that basically says, take a SwiftUI view with you, this is my view in here, wrap a dedicated view controller around it, and then you can use it as if it was a UI view controller, classic view controller, sorry for repeating that. The problem is that the moment you have your source view in SwiftUI and you have a button that needs to show you the detail, you don't know how to open that, because there's no way to retrieve your current view controller and say, okay, push this one or present this one modally. So again, how do we fit this in SwiftUI? Apparently memes are the main thing of this conference this year. I really love that. So we created a concept first, some concepts, and the first one was creating a route. Now, a route is just an object, simple basic object, actually a protocol, that it's used to define the transition between two screens. The basic protocol does absolutely nothing, and so does the empty route, which is a route that doesn't navigate, doesn't take parameters. It's just, the equivalent of a null object, but just to avoid to have nullable things in your code and avoid lots of compact map. Then you can extend this with another protocol called UIKit route that can have something declared in there, and it's just an execute method that is taking your source view controller. So now we need to have a way to provide these routes with the source view controller, and we'll get back to that in a moment. Let's take a look at some examples of this. So here's the navigation route. Our navigation route takes a closure as an init initialization parameter, returning some view controller. It can be, another parameter is it animated or not? And the execution of this route says that the moment you are called and executed by some other context, take the source view controller, see if you get a navigation controller, and then push the creation of the destination. As you can see in here, we get destination called the closure destination. So we are basically saying that every time we need to navigate in our app, we want to use navigation controller. Similarly, if you want to present something, we can have a modal route. Same approach here, just present instead of pushing. We can expand on this and try to provide a solution to the previous dilemma for Safari controller, creating the browser route. So you can have this object in your code saying that you want to have a URL, an external valid URL, hopefully. You may want to decide if opening externally or internally, like if you want to open a deep link to another application, you don't want to use Safari controller. And again, animate the change or not. And then you can just have your code saying that if open externally, use the UI application shared open, blah, blah, blah. Otherwise, create the Safari view controller and present it. This also lets us encapsulate the import Safari service thing in this route and not pollute our code with other Safari things all around the code base. Other ideas we might have are like the restart route, which is actually the main route we call when the application starts in the application app delegate, application did finish launching, saying that take the main root view controller of your window and change it with another one. We also created the back route and the exit route to go back when the detailed view model or view or whatever you have wants to go back, but maybe by asking some business logic before. Alert route to present error, or also share route to embed the UI activity view controller inside a single object. We create a lot of new routes. Now, it's nice to have them, but we're not solving anything. We are just moved our logic into something different. Now, the problem that's still in place is that first, we need to be able to pass the source of our navigation to our routes. We need a place where we are creating such routes in a convenient way. I didn't show you the business logic around creating route and which route needs to be created, and I didn't show any test. Now, to proceed with this, let me share the stage with my good friend here, Andrea.
Hello, everybody. So, Stefano, very talented developer, showed us how we can wrap all our presentation logic inside a simple protocol that does nothing. But at the moment, we need a lot of logic to try to understand how to put those view controllers one in front of the other, right? So let's introduce something more stupid, like me. Introducing the router, okay? This is just an object that we use because we like a lot combine, but we want to wrap it all around to don't show to the business logic specific. And it's just a stupid struct that contains a pass-through subject that emits roots. So what we do with this object? This object is specific for each scene and is passed from the view model. So for each scene, we have a view model because we are using model view model. And each view model have his router that emits the routes from the interactions from the view. So the view model is the chain conjunction between the view controller and the view. And the router is the object that passes the routes to navigate from the view to the view controller. Okay? So when we initialize a view controller, the first thing that we need to do is to subscribe to the router inside the view model. As you can see, inside the viewDidLoad method, we have a simple method that says self.subscribe to router. So this takes the router from the view model and listen to the routes that the view model is emitting. But what it does, it's a simple extension, platform specific, because this one is the one that we use specifically for iOS. We have another one for macOS that just takes all the routes from the router, checks if it is a UIKit route, so specific for this platform, and after that, move to the dispatch queue main and execute the route passing the reference from the current view controller. So, looks simple, right? But if you go back to the view model, we see that maybe there is something that is not so correct right here, because this object should be platform agnostic and should contain only business logic, but the business logic is up there. All this part is platform specific. So we have to do something to remove this code from here, because we have view controllers inside of our view model, and in our context where we could have some application with a lot of single modules that expose single features, we don't want to import all the features inside the same just to present a view controller. We want to encapsulate everything. So we need to decouple things. So how many times today you have listened the words dependency injection? Some. At least two. Okay. Let's introduce two concepts that we need to do this little trick. The first one is another stupid object with a stupid interface, because it's another interface that does nothing. It just marks the object as a root definition. And we can have a lot of root definition that are platform agnostic objects that just contains the parameters that we need to take from the view model to present the view controller with the correct context. The other one, it's something that it's similar to something that if you know dependency injection, maybe you can recognize. But do something different, because it's a root container. It works like a dependency container, but instead of take an interface, return a concrete object, it takes a definition and returns a specific root. Okay? Like what we do with dependency container, the root container is set up at the startup of the application before we present any view controller, because we need to register for each definition a specific root that we want to use to present a view controller. So in the app delegate at the finish launching, or in some part of your application that you are using to wrap up everything together, you can put this part of code where you can register all the definitions from all your frameworks and return the specific roots that you want to use to present the correct view controller for that definition, passing the context that you have took from the view model inside the definition, because this is just the interface of the definition, not a concrete copy. So the router receives the definition, and you can see that at the moment, no, let's see from here, because I can read the code. So in the product list view model, at the moment, we are not showing, we are not sending anymore the specific root, but we are sending just the root definition. Platform agnostic code, we are not using UIKit anymore. We can take this code and put inside a watchOS application, TV app, tvOS application, macOS application. The same view model we can use everywhere, okay? Very good, perfect. Let's go. If you remember, in the router, we had a pass-through subject that takes a root. Let's change it and use a root definition. So, also the router is business logic and doesn't know the root, the specific root, just the root definitions. The send method also takes a root definition and does just that. Is just that. Let's go back to the extension. Instead of taking the root from the view model, at the moment we have a root definition, and the router is showing a root definition. So the router itself have to use a reference to the root container that have all the registration for all the roots. And in the extension for the specific platform, we are taking the router and asking to him to resolve this root definition to get the UI kit root associated to it. Okay? After that, we have a view model that emits just root definitions and contains only business logic. And a view controller that takes a root with a platform-specific code inside and executes it. To test it, we, at the moment, are testing just the business logic, so we don't have to do so much. If our root definition is unquotable, we have a simple extension of XG test case that takes the view model, the root definition with the parameters that we expect to receive from the view model, and give us a closure where we can execute some code to simulate the interactions from the view. After that, I leave the stage to Stefano because I've finished, I think. Already? What do you think? We have the time for the live demo or
24
not?
minutes. Wow, we did super fast.
No.
Somebody is going to really be annoyed about this. Okay.
Come on, you have a lot of time for the live demo.
No problem. Okay. So far, so good. So we were able to decouple, apparently. So parameters on one side and navigation on the other. And apparently, we solved, in a very creative way, the navigation issues. Let's see if I can try to, hurt myself and duplicazione. Whoa. No, Orwell secrets are exposed now. How can we do that? Moving back to Xcode, yeah, okay. So yesterday, as I told you, we kind of had a workshop. So I'm going to reuse the code we used for this Twist workshop to show you actually navigation. And by the way, we're going to have a QR code at the end of this session where you can download this project if you are just curious enough to understand what was going on in our mind when we created all this strange stuff. So the application itself, let's see if it's still compiled or if I did break it apart. Since the Swift Heroes conference has some kind of APIs giving you back the list of speakers and talks, we decided why not to create a small completely unreadable app that displays the list of talks. So I could have used the accessibility talk probably before this morning. But anyway, in here you can see a list of talks, and it's actually navigating. Now, the thing that's happened, yeah, there was something that I forgot to do. It was to restore, to delete this, and okay. So this application has an app delegate. The app delegate is creating an app container. The app container is the place where you are throwing all of your dependencies, at least in our application. It's a dependency container, dependency inversion principle. I think we're going to have a talk about that sooner or later. I don't remember the exact schedule, but it's something I suggest you to watch. Now, in here we are setting up all of our routes at startup. And this means that we can create the global route container. It's not a singleton, but we only have one instance of that because it makes sense. And we're basically like a drawer. We are taking all the things that we need and putting them stuff into that. As you can see here, we are registering the restart route definition to be a restart route concrete object that it's creating our navigation controller for the main view. This is the only UIKit part you're going to see in the presentation because the actual views are a real one. I mean, are a SwiftUI one. Let's take a look at the view for a moment. So I get this view, and there's a list of items. We have a view model for the main logic, and every single item in the list has its own view model containing the talk detail entity object. And in here we are saying that whenever we are tapping on a detail, we want to have to open the detail. So we don't have the navigation stack, we don't have the navigation view. We are inheriting the navigation controller from the global environment. And in here we are just saying viewModel.open, the item I just selected. So if I double check my viewModel.open, you will see that it's creating a talk detail.route definition, the stupid object he was talking about. It's going to pass it a talk object and send it back to the router. As simple as that. Now, the nice part about this, I will stop for a second, is that if I move to my tests in here, I can create a test like this and say, whenever I click asynchronously on my imaginary view, and by calling the action on the view model, I want to expect a talk detail route definition. This means that if I'm messing up with the logic like this, my test is probably going to fail, hopefully, otherwise, let's see if it does. So this kind of test failed, yes. 2 plus 2 is 4, it's actually succeeding. This is the default test from Twist. I didn't know that from the main template. But the other one is failing because this navigation is not the expected one. So all of this complete mess is just to be able to test this stuff in a platform-independent way, okay? That's basically like that. And also to avoid having UIKit on the view model because it's not like the nice thing to do. So I'm moving back to my thing here, removing the return, and if I run the test, of course, it's going to work as expected. To take a look at how the registration part, so it's split in two, right? I'm sending object to my router, but if I don't register the way I should react with that, I'm not going anywhere, right? So in the bootstrap phase of the application at startup, I'm creating a very, let's try to have Xcode help us out. So I'm going to say route container dot register for the talk detail dot, you can nest types if you like it, or have, do not use Swift nesting, it's not a requirement. I want to register every time I'm dealing with a route definition, I want my closure, I wish I could code fast as shy. I want my definition to be transformed with actual parameters, so it's not a type anymore, it's the actual instance, to be transformed into a navigation route. Actually, let's have a model route, just to change what you just saw before, model route. With a create view controller, in here I can bind my destination UI hosting controller. Actually, I have a subclass of that. let me take this from here. It's not fun to watch somebody just type random code. And say, create my destination view model, create my controller, and return it. And the result when I run my app, you can unit test separately in a more UIKit dedicated section of your unit test, this registration part, so that you are safe, you are not having regression as you proceed in future. And now, if I open my detail with very tiny text, because why not, the presentation is modal and not pushed anymore. Now, another thing that you can do is to try to say, okay, let's try to do some TDD today. Do I still have time? Lucy, how much I have? Okay, thanks. Should be more than enough. So let's try to write a test. I want my view model to be able to navigate to a detail, so to navigate to the SwiftUI website. Let's be short and say test browse throws. I want the same router I'm having and also the same view model. And I want to say that I want to declare a function on my view model which is going to be browse. And I want to tap the top of my view and open the website. Is it pointless? Yes, but it's just to prove a point. So I can say expect. It's an extension on test, and you will have to write or to have that available in your code. Expect route definition on my view model equal to, let's say, router.browser.self. No, sorry, router.browser.url. Okay, like Mario Bowser, no. URL, and then, of course, I have to call init, and then it's going to be string, and then it's going to be HTTPS. Okay, I should have copy-pasted that, but I forgot to do that. SwiftHeroes.com. And then, God forbid me, I'm going to have a for some wrap here. Sorry for that, don't do that at home. Yeah, just invalidate the point of the entire talk. In here I get a reference to my view model if I want to use it conveniently, and then I want to say viewModel.browse, and the method is not existing yet, right? But let's create it. Sorry?
So test phase.
No, the test doesn't compile. If I unlock my browse, the test now compiles, and you will see that nothing happens. Actually, the test is failing because I'm not doing anything. What I can do now, and now I'm just uncommenting this, I can have my route object, my route definition sent to my router, and if I copy and paste my SwiftHeroes thing here, my URL properly, as you can see, the test succeeds. Let's try to also take a look at what happens in the app. No, I didn't put anything in the view, so one sec. I get this toolbar at the top with the SwiftHero friendly bird at the top. I want to have an on-tap gesture really quick and say viewModel.browse. So as you can see, just simple action sent to an external object and let him do the things. And now if I open and I launch my app and I try to click at the top, nothing happens. I see something in my logs here saying that I didn't find a route for your browser route. And now I can go back to my main app and say that I'm going to be quick here, and say that in my route container where everything is stored, where all the knowledge for navigation is stored, I want to say that whenever I have to deal with a router-browser route, I want to create a browser route. Browser route definition, I want to create a browser route way of navigating to the detail. So finally, if I run the application, and I click on Talks, SwiftHeroes website opens. just one more thing before I leave the stage. This was the demo, right? Okay, how do I put this in full screen again? Okay. This is where the applause was supposed to be. So please give me another applause. So this is a demo project. This is, as I said, it's the one we use for the Twist workshop. If you want some, I'm a big fan of Twist, and if you want some kind of entry-level approach to Twist, you can use this project. And also to try to explore what we did on navigation. It's a modularized, partially modularized application. Let me know what you think, and yeah, of course, if there are any questions,